solving problems involving permutation and combination. Determining if the problems to be solved using permutation and combination is not that easy. But we do have a couple of hints for us to use and for us not to have a wrong solution in solving such problem. And what are these? So for permutation, so aside from knowing that order does matter and order is important, so if we do think that the problem shows that changing the order or sequence creates something new or different, so therefore we solve that problem using permutation. Aside from that one, we may also look for this word, namely arrange or arrangement. So once we see this word from the given statement or problem, therefore we are to solve it using permutation. Aside from that one, if digits or letters are involved, we also solve that problem using permutation. Or if there's a specific position or title stated on the problem, we are to solve that using permutation. So when we are to solve the problem using combination, if order does not matter or is not important, it is under combination. Or changing the order or sequence will not create something new or will not create something different, therefore that problem falls under combination. Or if there's the word option or choices, so we are to solve the problem using combination. Okay? So let us deal with a couple of problems that we are to solve with either permutation or combination. So let us start with this problem number 1. Joshua bought 5 kinds of fruits such as apples, grapes, bananas, pomelo, and oranges. In how many ways can they arrange the fruits in a green bag? So is this problem to be solved using permutation or combination? So the answer is, so since there is a word here which is we are asked to arrange, there's the keyword arrange, therefore we have to solve this problem using permutation, okay, and not combination. So what kind of formula under permutation we are to use? So is it this one? No. How about this one? Not either. Not also this one. So this is the correct formula to use because there's just only a single data involved from our problem. So P is equal to N factorial. N representing the number of elements. So based on our problem, the number of elements that we are dealing with is 5 fruits. So therefore, upon replacing this N by 5, our solution will become P is equal to 5 factorial. So simplifying by factorial, in expanded form, that means 5 times 4 times 3 times 2 times 1. Then upon multiplying all of this, therefore we solve the problem immediately, giving us 120 ways. Okay. So again, this first problem was solved using permutation. Why? Because of the keyword arrange. Let's have another one. Maria bought 3 flat shoes of different colors, red, brown, and cream, upstairs of the shopping mall. They decide to put them inside the red eco bag, but it can only contain 2 pairs of shoes. How many ways she can arrange the boxes considering which is at the top and which is at the bottom? So, this problem falls under what? Permutation or combination? So, is it combination? The answer is no. So, this is under permutation. So, why is it so? Because again, there's the keyword arrange from our statement, from our problem. In case that we didn't manage to see this word, we can still conclude that this problem is under permutation because there's a specified position from our problem, which is at the top and which is at the bottom. So there's a specified position. Therefore, this is really to be solved using permutation. But which of these 5 formula are we to use? So this time, since we have a given number of shoes, which is 3, and we are only to use 2 from those or to place those 2 from those, so we are to use this second formula. So permutation of n, taken r at a time. So based on the problem, so what could be the value of n? So we are dealing with 3 flat shoes, so n is said to be 3. And r, since we are only required or we can only put 2 pairs of shoes on the green bag, so we are going to have 2 for the r. Okay, so 2 pairs of shoes only. Thus, we have the equation permutation of 3 taken 2 be equated to 3 factorial over 3 minus 2 quantity factorial. Simplifying the denominator, 3 minus 2, that gives us 1. So we do have now 3 factorial over 1 factorial. So upon computing this one, therefore, we may conclude that the answer is 6. Because 3 factorial is 3 times 2 times 1, while 1 factorial is simply 1. So 3 times 1, that gives us 6 divided by 1. So that's why we got 6. Okay, let's the third problem. Armac Motors designed a 22-seater jeepney. However, during this time of pandemic, only 14 passengers are allowed. Following the guidelines given by IATF, therefore, how many ways can the passengers fit the jeepney without considering the location of the seat? So, is this permutation or combination? So, this time, this is to be solved using combination. Why? Because it doesn't consider anymore the position. So, stated without considering the location of the seat. So, order or the position is not important. So, once the position is not important, so that problem falls under combination. So, combination of n taken r at a time. So, based on our data, n represents the number of elements. So, we do have 22-seater jeepney. And out of this 22, we are only allowed to have 14 of those seats. So, combination of 22 taken 14 at a time. So, to be converted into factorial notation as 22 factorial over 14 factorial times 22 minus 14 quantity factorial. So, simplifying the terms inside the quantity. So, we do have 22 factorial over 14 factorial divided by 8 factorial. So, we may use calculator to have the answer immediately. So, upon using our calculator, so it will give you the answer to be 319,770 ways. Okay? So, again, third problem was solved using combination because it stated that the position is not important. So, that falls under combination. Let's have the next one. Marina planned to make a salad. Thus, she bought carrots, potatoes, lettuce, cabbage, pineapple, quail, eggs, and chicken as the main ingredients. And how many options does she have if she can only put 4 ingredients at a time? Okay? So, is this permutation or combination? So, this still falls under combination. For what reason? There's the keyword option. So, keyword option is for combination. So, thus we are to use the formula combination of n taken r. So, based on the problem, our n is the number of elements. So, how many elements that we are dealing with? So, only a matter of counting the ingredients that was bought. So, we do have carrots, 1, potatoes, 2, lettuce, 3, cabbage, 4, pineapple, 5, quail, egg, 6, and we do have chicken. So, we do have 7 ingredients in all, and out of these 7, we are only to use 4 at a time. So, combination of 7, taken 4 at a time. So, we transform this into factorial notation as 7 factorial all over 4 factorial times 7 minus 4 quantity factorial. Simplifying the terms inside the quantity, which is 7 minus 4, that gives us 3 factorial. So, what we are not to simplify is 7 factorial over 4 factorial times 3 factorial. So, using our calculator, we will immediately get that the answer for this problem is said to be 35 ways. Okay, so, or 35 options. Okay, so the problem was solved using combination because we have the word option. So, option choices, the problem is to be solved using combination. Let's have the last problem. San Pablo City is not only known as the City of the Seven Lakes, but it's also known as the jeepney capital of the Philippines. All the jeepneys need to have license plate numbers. Each plate number consists of 6 digits. So, how many different license plates are possible? So, repetition is not allowed. So, is this one to be solved using permutation or combination? So, the answer is permutation. Why? Because on our problem, there's the involvement of digits, there's the involvement of number. So, involvement of letters, involvement of digits, the problem falls under permutation. So, which one is to use? Is it the first one? Okay, no. So, the second one, neither. Since repetition is allowed under this case, so we are to use the formula to wherein repetition is allowed. And that is the third formula. Okay? So, P is equal to N raised to R. N is the number of elements. So, on our problem, there's no element stated. We are just only told to have 6 digits. So, that 6 is for R. Okay? So, what could be for N? Since we are talking about digits, therefore, this implicitly involves the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, upon counting all of those digits, so we have a total of 10 elements dealing with. So, we have P is equal to 10 raised to 6. So, simplifying this one, so 10 raised to 6 simply 10 times 10 times 10 times 10 times 10 times 10. So, that's why the answer for this one is said to be 1,000. So, there is possibility that we can create 1 million license plate under this one. Okay? So, this is how we solve problems under permutation or combination. So, we may use those hints for us to solve the problem. But keep in mind, if you do think that order does matter, it is to be solved using permutation. And if you do think that order doesn't matter, it is to be solved using combination. Okay? So that's all. Thank you for understanding. Thank you for listening.